So we can now spawn one asteroid hazard. But that's far too easy to be a challenge. Let's spawn wave after wave of them. To get started, open the game controller script. The code that we've written works fine for spawning just one asteroid. How do we get several of them? Well, we could try to simply duplicate the code we wrote by copying and pasting it several times in our script. If we save this script, switch to Unity and enter play mode, it kind of works. We spawn several hazards, though if they collide with each other they do blow themselves up. But this is less to do with our code than the fact that we are spawning several hazards at the same time at random spawn positions. Is this the correct way to do things? Well, frankly, no. Let's return to our script. Whenever we write the same code twice or more, we are almost always doing something wrong. This code is terribly ugly. We need to delete it as soon as possible, and good riddance. But how do we execute this code multiple times without simply duplicating it? What we do is we put our block of code into a loop, and we execute that code each time we cycle through that loop. First, let's create a public int called hazard count to hold the number of times we cycle through our loop. We will be able to set this value in the inspector in Unity. Next, let's put our instantiate code into our loop. Indent the code we have written and write for, followed by a set of parentheses containing 2 semicolons. Surround our code block with brackets. We have now put our code into a for loop. We are not finished yet, but I wanted to show you the 2 semicolons here. When we are done writing our for loop, it will look very much like a function with parameters. Parameters in a function are separated by commas. In a for loop, they are statements, and they are separated by semicolons. In the declaration of the for loop, we need to initialize a counter, show the condition, or state how long we want to stay in the loop, and then increment our counter. In the initialize step, create a new int variable called I, which is set to 0. Our condition will be to stay in the loop as long as I is less than hazard count. Lastly, every time we cycle through the loop, we increment I by 1 using I++. Now, when we execute spawn waves, we will loop through this code as many times as we have set in hazard count, and then continue on with the function after the loop, which in our case is nothing, so the function will end. Save this script and switch back to Unity to test. Select Game Controller and change the hazard count to 10. Now let's enter and exit play mode a few times to see what happens. Very much like when we duplicated the code, we are spawning a number of asteroid hazards all at once. Many are destroying each other on the first frame when they overlap and collide. Better, but not much of an improvement. We have simplified our code, and we have easy control over the number of hazards that we spawn. But we don't have waves of enemies. What we want our code to do is wait after spawning each asteroid hazard before spawning the next, so we have a steady barrage of hazards challenging our player. Return to the game controller script. We need a public float variable called spawnWait to hold our wait time value. Logically, where we want to place our wait code is at the end of the spawn code in the for loop, before the code loops back and spawns the next asteroid hazard. After instantiate, write wait for seconds, spawn wait. This is the correct logical place in the code for us to wait, but this syntax does not work in C#. To have a function that can pause without pausing our entire game, we need to make this function a coroutine. And coroutines have some very specific considerations. For more information on coroutines, please see the lessons and information linked below. For this function to become a coroutine, we cannot return void. We must return IEnumerator. And our wait for seconds line must be written as yield return new wait for seconds. Lastly, we cannot call a coroutine like we call a function. We must explicitly use start coroutine with either the coroutine's name or the signature in the parentheses. To be polite to our players, let's create a new public float variable called startWait. And let's use this as the first line in our new coroutine. Copy the spawnWait line and paste it as the first line of the block, and change spawnWait to startWait. When we set this value in the inspector, it will be a short pause after the game starts for the player to get ready, get their hands on the controls, and prepare for action. Save this script and return to Unity. With Game Controller selected, let's set spawnWait to 0.5. So we will spawn 2 asteroids every second. And let's set the start wait to 1, giving our players 1 second to get ready. Save the scene and enter play mode to test. And now we have a steady stream of hazards. Let's try that again. Very nice. But when the first 10 asteroids have cleared the screen, there is nothing more for the player to do. We could increase our hazard count to 50, 100, 1000, but that could get monotonous, and if our player is good, they could eventually run out of hazards to shoot or avoid. Return to the player controller script. We want to create continuous waves of hazards until our player is destroyed and the game is over. We can do this by wrapping our instantiate loop in another loop. Grab the for loop code that we have written and indent that code. Write while, followed by parentheses. Wrap the code block in brackets. This is a while loop. With a while loop, we will continue to cycle through that loop while the statement in the parentheses is true. Let's say as long as A is greater than B, or whatever statement our code needs. In this case, we will say while true. And of course, true will always be true, so this becomes an infinite loop. We will discuss how to break out of this infinite loop in another assignment. The way this works is in our while loop, we execute our for loop, and we instantiate our wave of hazards based on our hazard count. When we're done spawning our wave, the while loop brings us back to the top of the block and we execute the for loop again. To create a gap between our waves, we need to wait, this time at the end of the while loop. Write yield return new wait for seconds. Write public float wave wait. And the amount of time we wait between waves will be represented by wave wait. Save this script and return to Unity. We can see our game controller component now has a wave wait property. Let's set this to 4. Save the scene and enter play mode to test. There's our first wave of 10 asteroids. We have a pause between waves as we wait in our while loop. And there is another wave as we execute our for loop again. Another pause, and wave 3. And this will continue until we exit play mode. This is starting to look like a real game. There is one last step we need to do before we sign off on this segment, however. Look into our hierarchy while we're playing the game. It's full of used explosion clones. Every time we destroy an asteroid, the asteroid spawns an explosion, and there it stays. Currently, we have only 2 ways of destroying things in our game: when they leave the boundary trigger box, and by contact. Neither will work in this case. We will need to write another way of destroying things: by time. Exit Play Mode. Select the Scripts folder and use the Create menu in the project view. Choose C# Script. Unity creates new assets where we are focused in the editor. By selecting the Scripts folder before we created our new script, Unity created it inside the Scripts folder, so there is no need to file it away. Rename this script Destroy by Time, and with the script selected, open it for editing. This script will be very simple. After removing the sample code, write void start destroy game object. Now this seems a bit crazy, destroying our game object the same frame it's instantiated, no? Well, destroy is very useful. For more information on destroy, see the lessons and information linked below. One of the parameters in destroy is time. We can specify a wait time before destroy takes effect. Let's write public float lifetime. And let's copy lifetime. After game object, add a comma and paste lifetime. Now, when our game object is instantiated, like a ticking time bomb, the object will set its lifetime and destroy itself when the time is up. Save this script and return to Unity. Select the Explosions folder in Prefabs VFX. In the Explosions folder are our explosion prefabs. Select the asteroid explosion and using the Add Component button, select Scripts. And choose Destroy by Time. Set the value of lifetime to 2. We can also add a script this way to multiple items. Let's update all of our explosion prefabs. Select the other 2 explosion prefabs, and using multi-object editing, use the Add Component button and select Scripts. And again, choose Destroy by Time. And set the lifetime value to 2 as well. This adds the script and sets the lifetime value on both prefabs at the same time. Save the scene. Enter play mode and test. We can see the explosion clones are no longer accumulating in our scene, not even the player's explosion. We almost have a complete game. In the next assignment, we will add audio to our scene, including explosion sounds and laser guns blasting.